All right, welcome back to Mr. P Helps with Algebra. This is Unit 4, Topic 2, Lesson number 5. We're going to be multiplying binomials in this lesson. We're going to be doing it with something called area diagrams. All right, we're going to start off with a warm-up, which happens to be on multiplying monomials. Monomial mean one part. So we've got x squared times x to the fifth times x to the fourth. So you're going to use what's called the product rule. The product rule states that whenever you multiply something with the same base, you simply add its exponents. 2 plus 5 makes 7, plus 4 makes 11. All right, this is also a product rule question because you're multiplying. Product means multiply. It's the answer using multiplication. First thing you have to do is you have to multiply the coefficients. 3 times negative 4 is negative 12. Positive times a negative. Keep the bases the same, so x stays x and y stays y. We just need to look at the exponents. There's 1 right here plus 4 more right here makes x to the fifth, and y to the 1 plus 3 makes 4. All right, question number 3 is also a product rule question. Coefficients, negative times a negative is a positive 8. A and B are the two bases. There's 1a here, plus 5 more makes 6 a's, or 8 to the 6th power, and b to the 3rd power because there are no b's up here. So 3 plus 0 is 3. All right, question number 4. Now we've got a new rule. We got this is called a product to the product rule. So the power to a power rule. I can't believe I said that. Power to a power rule states that whenever you have a power raised to another power, you multiply the two powers. But also the coefficients. The coefficient also has to be, everything inside the parentheses has to be raised to the power of 3. So 4 times 4 is 16 times 4 again is 64. B to the 6th, y to the 9th, because like I stated, you just multiply the exponents. 2 times 3 is 6, 3 times 3 is 9. All right, question number 5. Notice this time we have product rule, power, and power to power rule. But you have to do exponents first. So starting on the outside most, so 6 squared is 36. X to the third to the second becomes x to the 6th. So I've just changed this into this. Now you don't do this squared because only what's in this parenthesis was squared. Now I'm going to use the product rule. This times this. Negative 3 times 36 makes negative 108. X to the 7th, y to the 2nd. All right, last one. So we've got power to a power rule. So that's m to the 6th, n to the 8th. And then bring down your minus 1/2, which you can change to a decimal if you want to. I mean, that is the answer. That's as much as you can simplify it. All right, so like I mentioned earlier, so this is able to write all the 3 different ways of writing quadratics: factored form, vertex form, and standard form when using these area diagrams. So we've got x squared was the basic block, and then we want to extend one side by 5 and the other side by 2. So if I make my area diagram like this, I extend by 2 and extend this side by 5 with 5 longs. So I've got 1 flat and 7 longs total, and that's going to take 10 units in order to complete that rectangle. So 3 ways you could write that. Well, we have factored form, which is right there, x plus 5 times x plus 2. That's called factored form because factored means what times what equals that answer. So those are 2 products, this times this. If you look at the area diagram, we've got 1x squared. We've got 7, because there's 2 here, and then 5 more longs on the side. So that's 7 longs altogether, 7 x's, and 10 units. So there's your standard form. Now we're also going to do vertex form just for the sake of doing it. If I was going to try to make this into a square, because that's what we're doing, we're completing the square, I would put 3.5 of those longs on both sides, because there's 7 of them. You put half on each side. But the thing is, when you have 3.5 this way and 3.5 this way, how many units would it take? Well, 3.5 times 3.5 is 12 and 25 hundredths. But you've only got 10 units. If we've only got 10, but we need 12.25, that means we are missing 2.25 units. Okay, and I can't forget about the square. There it is, vertex form. Put this, this, and this all in a graphing calculator, and you will see that they are all exactly the same thing. All right, I'm not going to make a diagram for every single one of these, but I do want to make sure I show you how to write it in all 3 ways. So once again, a block was extended by 1, 2, 3 this way, 1, 2, 3, 4 this way. That means you're still going to need 12 blocks to complete that rectangle. So that's an x plus 3 times x plus 4 rectangle. because that's the dimensions, x plus 3 here and x plus 4 this way. Now that would be equal to x squared plus 7x plus 12, because those are the pieces that we use. And that is equal to x plus 3.5, because once again we have 7 longs. 3.5 on each side means we need 12.25, but this time we've only got 12, so we're missing 0.25 of a unit. So we're only missing one part of 1 unit in order to complete that square. All right, next question. The original square was extended by 4 inches only on one side. So a diagram would look something like this. You got 1 flat plus 4 longs on one side, and it wouldn't take any units to complete that rectangle because it already is a rectangle. It's a rectangle of x plus 4 times x. And that would be this. That's factored form, and this is standard form because those are the pieces that I used. And vertex form, well, I can make an x plus 2 square if I take these two pieces and put them over here. But then I'd be missing all 4 of the units in order to complete that square. And that would be the vertex form. Oh, I missed a question, didn't I? So question number 4. Extended by 5 inches on each side. So that's going to be x plus 5 times x plus 5. Well, that's easy to change that to vertex form because that'd be an x plus 5 square with all the units. We don't need to add or subtract anything. And then standard form, that would be x squared plus 10x plus 25. Now, what you might be noticing is with all these problems that we've been doing, the b term in standard form is always what you get when you add these two numbers together. And the c term in standard form is always what you get when you multiply the two numbers by each other. So now that you've noticed that, hopefully we can do all the rest of them with some ease. So the next one is x plus 2 times, one side is 6 inches than the other. So one side, one block was extended by 2 inches, and one side and 6 inches on the other side. Okay, so that's x plus 6 over here. So standard form. Remember what I just said a second ago. You can simply add the numbers to get that's the how many longs that you need. So that's plus 8x plus 2 times 6 makes 12 units. There you go. We got 8 longs, so that means we got a perfect square of 4 longs on each side. And that means we need 16 units, but we've only got 12. So therefore we're missing 4 more units to complete that square. All right, question number 6. Now we're going to deal with negatives. One side's extended by 2 inches, the other side's decreased. And we call this differences of squares. So it's x plus 2 on one side, and the other side's got 2 red longs. So it does complete the square. It has 2 greens and 2 reds, one on each side. And then you would need 4 units in order to complete that square. Well, I just said basically the vertex form. Oh, no, that's not the vertex form. So if I simplify this, I completely mess up. This is not what I said. It's supposed to be minus 2, differences squares. And that means that if you add the 2 together, then they cancel each other out. And then you multiply and you get negative 4. Or minus 4. So x squared minus 4. This is called differences of squares. So because when you draw the diagram, these 2 green longs and these 2 negative red longs, and these are positive over here, these make 2 sets of 0 pairs. Meaning this plus this makes nothing and this plus this makes nothing. Both sides of the original square block were decreased by 3. So that's x minus 3 times x minus 3. By the way, the last one can't be done in vertex form because vertex form would actually look exactly the same. It would just be x minus 0 squared, but that's just x squared with a minus 4 on the outside. But honestly, that's really just x squared minus 4. So I think these two are really just the same thing. This one's going to be x squared minus 6x plus 9. Once again, add them to get the b term, multiply them to get the c term. And obviously the vertex form is going to be very easy because it already is a perfect square. All right, what comes next? Number 8 and 9. I'm getting at 9 minutes. The original square block was extended by 5 inches on one side and doubled on the other side. Okay, so I'm going to use that area diagram to do that. 1, 2, 3, 4, 5. Now, if I want to double everything, so this side and then I want to double it going this way, I would make another flat and then 5 more long. So basically what I end up with, that's the factored form, and the standard form is x squared plus, oops, see daisies. Let me go back for a second. I messed up because the other side is not just x. This is 2 x's. Sorry for that mistake. That's the factored form. Let's try that again. So then we got 2 flats plus 10 longs. And then if we were going to, I'm going to stay away from vertex form for that for right now because we have a leading coefficient. So let's not worry about that for right now. Each side of the original square block is tripled, then decreased by 1 inch. And then decreased by 1 inch. Okay, each side of the original square. So each side was tripled, but also subtracted by 1. So that would be 3x minus 1 times itself in both directions. And that's going to give you 9x minus 6x plus 1. Now, you might see what I did there. I multiplied these by themselves and got this. I multiplied these by themselves and got this. And then I did the outers and inners. Outers, that gives me negative 3x, and the inners also negative 3x. Combine those, you get negative 6x, which then brings me to the homework. The homework is a lot like we just did a second ago. Now I can use FOIL, or I can use my area diagrams, however you want to solve it. It's fine by me. Or you can just say to yourself, well, hey, there's no leading coefficients here, so it's going to be x squared. Add them, and you get negative 4x, and multiply them, you get negative 45. Done. This one, you do have a leading coefficient. So you know what? I'm going to use FOIL. First, outer, inner, last. 4x times 2x is 8x squared. 4x times 7 makes 28x. Negative 3 times 2x is negative 6x. And negative 3 times 7 is negative 21. Now I'm going to clean that up a little bit and simplify the two terms in the middle. 28 minus 6 is 22x. And bring down the minus 21. Okay, let me change colors so you can see what this problem is. First of all, 5x minus 3 is squared. So that means basically it's multiplied by itself. So the first step I'm going to do is multiply it by itself. Now this is a special. This is a square. So when you're doing squares, you just simply multiply the first terms by themselves. That's 25x squared. Multiply the two last terms. That's going to give me plus 9 at the end. And then multiply these two terms and double it. 5x times negative 3 is negative 15. Double it, you get negative 30. And you might be wondering, why am I doubling? Because the outers and the inners are going to be both be negative 15x. So that's a trick way of doing it. Okay, these aren't. So I'm going to have to use FOIL. So that's 10r squared. Outers is 35r. Inners is negative 6r. And last is negative 21. Clean that up a little bit. So we got 10r squared plus 29r minus 21. Pen didn't work there. All right. Last two questions. Almost done. I'm going to FOIL again. 3x times, okay, first, outer, inner, last. So that's 6x squared for the first. Outers is 9x. Inners is negative 14x. Come on, pen. And last is negative 21. Okay, clean that up. We got 6x squared. 9 minus 14 is negative 5x in the middle. Because those are like terms, they can be combined. Nothing here can be combined because this is x squared, this is x, and this is just a constant. Can't combine things unless they are exactly the same variable with exactly the same exponent. All right, last one, 4x plus 3 times itself. Looks like this. Okay, so that's 16x squared. Outers would be 12x, but since it's a perfect square, I can just double that to make that 24x, because the inners are going to be exactly the same, perfect square. And 3 times 3 is 9. Okay, that looks to be it. Please give it a like if I helped you learn something, and definitely subscribe if you haven't done so already, and have a wonderful day. Thanks for watching. Bye-bye.